Alright guys, this video is going to be a two-parter. In the first part we're going to discuss what JavaScript is, and in the second part we're going to do a bit of intro programming with JavaScript. So let's just get right into it. So JavaScript is a high-level programming language, and it's primarily used for web development. Now web development, well, that's just the complete process of planning, developing, and deploying a piece of software to be used on the internet or through an internet connection. So let's update a distinction, and that's the distinction between a web page and a web app or an app. In the old days, the idea of a web page was distinct from the idea of an app. And so in the old days, you'd go to a web page, you'd navigate to a web page, and you'd have a certain type of experience, something largely static, less personal, less interactive. You then maybe close your browser, you go offline, or maybe you stayed online, and you'd open up some sort of application, something like Ventrilo, or maybe a game like Counter-Strike. And with that app, you'd have a different type of experience, something more personal, more feature-rich, more customizable. Nowadays, these two domains, the domain of a web page and an app, are largely blurred. And that's just to say that the experience you have with an app should be similar or exactly the same as the experience you have with that app's website. And so an example of this would be YouTube. The experience you have with the YouTube mobile app is largely similar or exactly the same as the experience you have with YouTube through its main website. Now JavaScript, it provides this level of interactivity between you, the user, and the web pages you visit. Basically, JavaScript allows websites to behave like apps, so more feature-rich, more personal, animations, more vibrant. Now, JavaScript programs, they get compiled and interpreted. They used to get exclusively interpreted. Let's move this over here. But now they get both. They get both compiled and interpreted. And so what's the difference between interpreting a language and compiling a language? Let's tackle interpreting first. Interpret. So when we interpret a language, let's just say these are lines of code. When we interpret a language, the interpreter goes line by line. It takes the line, it translates it into machine code, and then it executes the line. It then goes to the next line, translates that into machine code, and executes that line. Now the great thing about going line by line, executing one line before going to the next line, is that say you have an error on line 2 right here. Your interpreter would go to line 1, it would translate to machine code and then execute it. It would go to line 2, it would translate into machine code and then execute that line. But since there was an error in the code on line 2, it stops your program and it doesn't go to line 3. This is different from how a compiler works. Let's zoom out a bit. A compiler takes all of your source code, so these are lines of code again. It takes all of your source code, translates it into machine code, and then executes the code. So the disadvantage to this is that you can actually translate errors into machine code, and then you'd have to execute all of the code in order to know there was an error there. So what's the advantage of compiling? What is the advantage of using a compiler? Well, it's faster. It's faster to translate all of your code into machine code and then execute it, as opposed to going line by line by line. And so the reason why JavaScript gets compiled now as well as interpreted is because it takes from both of these methods. It takes pros from both these methods. It takes the error checking or the bug checking of an interpreter, and it takes the speed of a compiler, and it combines them into something called JIT, or just in time compiling. And all that means, this just in time, it means that based on what code needs to be executed and when, the JavaScript engine will compile whole blocks of code and have them waiting somewhere in the wind. On other lines of code, it'll execute them directly. So we're going to get into what a JavaScript engine is in a bit, but just understand that this just in time means that it maximizes for efficiency. Code that can be compiled ahead of time is compiled ahead of time. Code that can't is executed line by line. So what does all of this compiling? What does the interpreting? What manages the execution flow of our JavaScript code? When should blocks of code be executed? What should happen if there are errors on lines of our code? What manages all of this? Well, that would be let's zoom out a bit. That would be the JavaScript engine. Let's move that up. Now, the JavaScript engine, it's implemented in different ways, but they all basically do the exact same thing. The implementations of a JavaScript engine do the exact same thing. And what do they do? JavaScript engine, let's do a paste. Well, JavaScript engine, it checks our code for errors. Zoom in a bit. Checks our code for errors, it optimizes code using compilers, it manages memory, and it does this very important thing called event loop management. This is very important to modern day JavaScript. We'll get back to it in a second. And so it decides when and what code should be executed, what order it should be executed in. Now, JavaScript engines are implemented in browsers, and so different browsers have different implementations of their JavaScript engine. And so Chrome, let me do a copy and a paste here. Copy, and we'll move the board here. We'll do it like that. And so Chrome, their implementation of the JavaScript engine is called V8, and that's this guy here. Safari has a JavaScript implementation called JavaScript Core. Firefox has SpiderMonkey, and Internet Explorer has Chakra. Now, the JavaScript engine, it traditionally sat in the browser, and so if you wrote JavaScript code and you wanted it to execute, you'd have to execute it through a browser. That was until someone took Chrome's V8 engine, they took it out of the browser, and they allowed you to execute it on servers, so something like a Linux bash or a Windows shell. So in this a different environment, we call that environment a Node.js, and so Node.js is just Chrome's V8 engine implemented outside of the browser. This really changed the game in writing JavaScript. Now JavaScript is like a legitimate programming language that can run servers on the back end, run code on the back end, as well as in the front end with the browsers. Another very important feature of modern JavaScript is the idea of a concurrency model philosophy. What this means is that certain parts of your JavaScript code events are executed by different parts of the JavaScript engine. And so no one line of code or a block of code logic interferes with the execution of another line of code or block of code logic. So what does that mean? What does that look like? So let's picture these guys as blocks of code logic. And so the JavaScript engine would go to line 1, it would execute line 1. Line 2, execute line 2. Let's say we wanted line 3 or block 3 to be executed at a later date. We'd specify this to our program. It would take line 3 or block 3 and it would move it off to a different space that we'll get to in a second. It would then go on to execute line 4. When it was time for line 3 to be executed, it would recall line 3 and then execute line 3. And so this is what we mean by what's meant by JavaScript is an asynchronous or an out-of-order language. It has the ability to execute lines of code without any one line of code or block of code interfering with the execution of the others. And so the three main structures that allow this functionality, those are called, zoom out a bit, those three structures are called the stack, we got the heap, and then we got the queue. And so the stack is a structured area of memory that works on a LIFO, it's a architecture, a last in, first out. So it's just a structured area of memory where frames are pushed, and frames are just codes of blocks of code logic. And so frames are pushed onto the stack like a stack of pancakes, and the opposite order that they were put on, they get executed. So frames get put on the stack, and then they get executed off of the stack. The heap is an unstructured area of memory. You could think of it like a notepad for your day. It's an unstructured area of memory used to place and to keep, to hold. Variables, data that your whole program is going to need. So maybe like things like you want to hold names in between blocks of logic, numbers, things like that. Just think of it as an unstructured scratch pad or notepad. Now the queue is where the modern JavaScript gets its ability to go out of order. When I talked about up here line 3 being put in a place for holding, I was talking about the queue. So queue is a queue, like a list. And when you designate a function to be called back later, we call those callback functions, and we'll get into that in later videos. And so the callback function is put into the queue. And when there's time to execute that function, that piece of code is taken off of the queue, put onto the stack, and then executed off of the stack. So these three structures here, the ability to handle real-time right now execution on the stack, to have things wait for later, the queue, and then the heap, the unstructured order or unstructured space of memory. These things help create the loop in the event loop cycle we got up here. So what did we learn in this video? Well, let's zoom out. We went over the difference between an interpreter and compiler. We saw that the interpreter went line by line and executed lines as it went. This allowed for greater error or bug checking. We learned what a compiler was, and this translates all of the code into machine code before executing. That allows for faster execution times. And then we saw that JavaScript was a just-in-time compiled language, which means it uses an interpreter and a compiler to execute the tasks. And then finally, we went over a concurrency model philosophy, which is just the event loop that helps manage when code gets executed, the stack, the heap, and the queue. So in the next video, part 2 of this video, I think I mentioned in the intro to this video that this would be a two-parter. In part 2, we're going to do some actual programming. We're going to step away, not completely away, but less abstract, more practical stuff. In the next video, we'll use JavaScript to write variables or explore variables and functions. So don't forget to follow, subscribe, thumbs up, all that good stuff. And I will see you guys in the next one.